Today our topic is coastal protection. Previously we have discussed about coastal erosion, whereby we suffer shoreline retreat when there is net soil loss from the coastal region. Coastal protection is thus the important approach towards coastline defense. There are two approaches. One is structural approach, which involves the construction of hard structures, and the other one is beach rehabilitation, which is a soft approach. In terms of design considerations, there are two aspects. One is the structural aspects, which look into the stability of the structures, and the second one is the functional aspects, which look into the geometry of the structure to satisfy the design functions. So specifically in this course, coastal engineering, we will be looking at the functional aspects of the coastal structures. For example, we will be looking at what is the size, the length, the width of the structures that is required. Once this dimension of the structure is determined, then the structural aspects will be designed by structural engineers to determine the type of reinforcement, the type of concrete to be used, etc. There are various types of coastal structures, and here we list 5 main categories which have slightly different design approach between one another. The first category is the cylindrical type structures, most commonly represented by piles or pipelines or cables installed in the coastal environment. Then we have the large single unit submerged or partially submerged structures, whereby the size are typically much larger than the wavelengths in the area that it is being built. The third category is vertical face rigid structures, where the pressure distribution on the sea side of the structure plays an important part of the structural stability. Next, we have the moat type floating structures, whereby it does not occupy the entire water column, and thus it allows the transmission of wave energy, and at the same time it will be subjected to movement. The last category that we will look at is the rubber moon type structures, whereby the structure is made up of individual armor units, which needs to be designed to remain stable under wave attacks. So as we proceed in this lecture later on, we are going to look at some of the design principles for these different categories of structures. In a typical design process, it begins with, of course, the knowledge, the theoretical understanding and experience of the engineers. Usually the engineers will produce a preliminary design, and the design will be evaluated using suitable model, whether it is a physical model or a computational model. If not, in most cases for important projects, both physical and numerical model will be used in order to validate the results obtained, and so that the effectiveness of the design can be ascertained. Now, once the functional requirement of the design has been evaluated, then the detailed design, typically which involves the structural design, will be carried out in order to produce the construction drawings. And from here, the implementation or construction will be carried out. When the structure has been constructed, then it basically begins to function. However, long-term monitoring will be very important in order to find out whether the design a typical coastal structures design process is illustrated here. It begins with getting the right expertise or engineers with the necessary knowledge, theoretical understanding, and also experience. The engineers will usually come up with the preliminary design, and the design will be evaluated using suitable model, whether it is a numerical model or a physical model. If not, for most critical structures or projects, both numerical and physical models will be used in order to validate the results, both in terms of the functional aspects of the structure and also to look at the impact of the structures to the coastal littoral processes. Once the functional design, the dimensional design of the structures has been confirmed, then detailed design of the structure will be carried out to produce the construction drawing for implementation, which means for construction purpose. When the structure is completed, it basically already begins to function, and in order to find out whether the structure has been designed correctly and that it functions as intended, long-term monitoring is very important. By installing suitable gauges or frequent visit to the site, and also a suitable on-site measurement carried out at regular interval, engineers can find out whether the structures has the positive impact as desired or whether it has actually induced some unprecedented or unexpected negative impact to the local environment, including the littoral processes. So the monitoring actually provides information, data for engineers to improve the design, to carry out the maintenance work, and also to apply the lesson learned to future projects of similar nature or future projects in the localized area in close proximity. So essentially, the entire process of coastal design is a trial and error process, because every coastline is different and every coastline is subjected to different coastal climate and localized processes. And so the use of appropriate safety factor and also cost consciousness is highly important in order to make sure that a good solution is provided. In order to carry out coastal design, the typical data required are as listed in this slide here. We need information regarding the physical characteristic of the site, which includes coastal geometry, bathymetry, beach profile, as well as historical and current satellite imageries, so that we are able to look at the changes that has taken place in the past, specifically related to the shoreline changes or sandbar changes. We also need geotechnical site investigation data to provide us with information regarding the bearing capacity of the foundation, so that we are able to determine whether the proposed structure can be adequately supported by the seabed or the ground. Littoral material can be determined based on grab sampling at various locations, so that we have the sediment size distribution, and this can be related to the shoreline changes, so that we can find out what is the net alongshore transport or onshore offshore transport in the particular site area. We need information regarding the wind and the current speed as well as direction. We need the wave climate, characterized by the significant wave height and wave period. We need the long-term water level changes represented by the tidal fluctuations that will include tidal datum such as mean sea level, mean high water spring, mean high water, is highest astronomical tide, as well as the rest, the lower counterparts like MH, WN, LL, W, and LAT. So please check again that you are familiarized with all these terms. For a coastal area where there is a river outlet, usually we will also need to find out regarding the river discharge and river sediment discharge, which will give us the sediment input from the upper catchment. Any sedimentation history or dredging record in the local area will also be very important for us to work out the sediment budget of the particular segment of coastal area. And last but not least, where water quality is a concern, then we will also require the coastal water quality data. Using the data obtained, some analysis that needs to be carried out will include analysis of the wave pattern, whether there's any diffraction, refraction, or reflection in the site area, wave setup and run up, wave breaking and breaker type, wave and current forces such as drag or pressure on the coastal structures. We will discuss more about this later on. We also need to analyze any possibility of the occurrence of standing wave or siege, the local circulation, meaning the local flow patterns, the littoral processes before and after the construction of the proposed structure, and of course the structural functionality and the structural stability. Most of these can be done using the theories and the methods that we have discussed in the previous chapters, but otherwise typically a numerical model or a physical model will be used to obtain the data so that we can have an objective understanding of the site condition and how it is going to respond to the proposed solution. Additional design consideration will include past experience or past performance of similar type of structures installed somewhere else or installed in a nearby coastal area. This will provide valuable information for the design engineer to know whether the design is adequate or whether it needs to be fine-tuned. In the process of proposing the solution, engineers also need to be very clear whether the solution is meant for long, mid, or short-term solution, and also to evaluate the long, medium, or short-term impact of the proposed solution. The structure or approach taken must comply with the local or government planning requirement. It has to typically fulfill acceptable aesthetic value, especially amongst the local, and also especially if the area is popular among tourists. The proposed solution must also be considered from the perspective of social and environmental impact, and where necessary, environmental impact assessment may be required. The engineers will also need to evaluate the risk and reliability, including construction risk and construction impact, meaning that these are temporary impact only during the construction stage, meaning that this impact can also have lasting changes to the local shoreline if they are not properly managed. Based on the proposed solution, materials availability is another important consideration, because most coastal structures proposed will be relatively massive in size, if not occupy a long stretch of coastline. So material availability from the nearby area is very important in order to cut down the transportation cost. The maintenance and recurrent works required to make sure that the design structure can continue to function as required will have to be looked into. So this involve the evaluation of both the initial cost as well as the maintenance cost in order for the financial part of the options to be evaluated from the perspective of lifetime costs and their net present value comparison. This slide here shows some of the local guidelines which are applicable in the process of coastal design. These include the Garis Panduan dan Piawaian Perencanaan Kawasan Pantai, guidelines for preparation of coastal engineering hydraulic study and impact evaluation, and DID manual on coastal management. These are important references on top of some of the popular design guidelines from USACE or from the Europe. Here, let's get a simple idea about how coastal design is being carried out. First and foremost, for example, if we look at the figure on the left, we have a coastline over here with an offshore island, and this is the stretch of the shoreline that requires coastal defense. So in order for the engineers to carry out a proposal and subsequently the design for the coastal protection along this stretch of the coastline, both hard structure or soft approach may be considered. In order to do that, we will have to look at what is the coastal climate in this region. That will involve getting the information on the wind, the wave, the tide, and the current, whereby on-site measurement may be required. Typically, offshore wind or wave data can also be used, but in order to find out what is the localized wave patterns, wave height, etc., the offshore information will have to be analyzed to give us the near shore coastal climate. This can be done, as we discussed, in the topic of wave mechanics, and this can be done using software as well. Now, we also would like to know what is the profile of the beaches along this stretch of shoreline, what is the bathymetry, and also the sediment material in this area. We can use satellite images to find out whether there's any changes of this shoreline historically, whether there's any sandbar formation, any shoreline retreat or erosion, for example, and also to find out what is the coastal littoral process is like, whether there is a net loss or net accretion. So all this information are vital. Now, if we are going to construct a hard structure here, then we also want to find out whether this section of the coastline have good foundation. So that's where the SI may be required to be conducted. Now, let's say at the end, the engineers decided that they need to build seawall like this on the shoreline. This is the beach profile. Then here, the functional requirement of the structure will first be designed, which means that we will have to find out what is the sizing of this seawall, how high it should be in order to take care of the highest tide and also incoming weight, and how low it need to go in order to make sure that the toe does not have any scouring problem. And also we need to look at the overall stability of the proposed structure when it's under these various forcing, whether it will collapse, whether it will slide or overturn, etc. So that is the functional design part, to make sure that the structure is able to protect this segment of the beach from the attack of the wave against the problem. Presumably the problem is erosion, and also it is high enough to prevent overtopping of wave, and deep enough to be stable, and also guard against any scouring or foundation failure. Now, once this functional requirement, the dimension of the structure has been designed, of course, again, we will have to make sure that the foundation is strong enough to bear the overall loading in post. If that is not the case, then we will have to look at alternative. But let's assume that right now this structure, the solid one here, is passed. We do not need a bigger one, we only need this smaller one. So finally, the actual design of this seawall, which requires steel bar reinforcement, which requires specific grade of concrete, a certain concrete strength, etc. That will be the structural design of the to be done by the structural team of the engineers.